Okay, now test here. I want them back, so don't keep them, don't crumble them up, they're mine. You do not get to keep them. So you at least get to see your score. You can make a quick decision if you want to retake it. Retakes are due by the end of the week. If you have any late work or redo assignments or fixes, they're due by Thursday this week. Thursday, that's the 22nd, I think. So keep that in mind. If you turn them in Friday, like, oh Lord, I forgot, I will literally tell you that the recycling bin's on the back. Don't make me do that to you. Thursday they're due. Okay, and again, I'll take those back here in a second. We're going to go through the test scores. We'll go through every question. I'll make fun of answers that I think are silly. That type of thing. You guys know the drill. We've done it in the last one. We'll do it again. We do it every test. I don't want to leave you hanging like, why did I get this wrong? How many points was it worth? That type of thing. I want you to know exactly what it was worth and why you missed it. All right. Now, the little handout I'm giving you is a little property sheet. It's really just vocab terms. We're going to talk about the start of this stuff today. And then tomorrow we'll get into it more in depth.
All right, did everyone get a property sheet? Okay, all right, we're gonna talk about that property sheet later. That's gonna be used on your next test, don't lose it. It's kind of like the property sheet I give you for volume and area and all that. You're gonna need it for the next test. It will be a pretty helpful guidance to study guide. I think that's what I called it. All right, okay, so test out of 49. It's pretty standard. Semester tests are always worth a lot more. But my normal tests are about 30 to 50 points, kind of in that ballpark, and you guys hit 49. All right, so vocab, let's kind of walk through these. Let's walk through the definitions. There are some goofy answers that I saw for some of these, so we'll just kind of walk you through it. Sorry, it's really blurry. It's a copy of a copy, sorry. Okay, again, I'll take those things back so I don't crumble them up. But a solid that encloses a single region of space, that's called a polyhedron. Right? A polyhedron is a solid, it's a three-dimensional object. The single region of space, it's not a polygon, because polygons aren't solids, they're two-dimensional. A decagon is a figure that contains 10. Distance around a circle is circumference. A figure that has all angles are congruent, that's equiangular. It blows my mind somebody couldn't get equiangular right. It literally says equal angles, like equal angles in the inside of that name. It really threw me for a loop. A type of polygon that contains points in the interior and does not cross the edge is called a convex. That's the book definition, sorry. It's the one I kind of warned you of when we did the PowerPoint. We had concave on the practice guide. It was convex here. Yeah, it's just a terrible definition, but that's the one the book uses. But convex, it's a type of polygon. The side of the polygon where the polyhedra, where the two faces meet or intersect, is called an edge. That's where the faces meet. It's like the edge of my wall. Volume is the number of cubic units contained in a solid. How many little cubes, sugar cubes, are in an object? That's volume. Rhombus is a type of parallelogram that contains 4 congruent edges. I think the goofiest answer I had for a type of parallelogram that contains 4 congruent edges, somebody put circumference. Circumference, like not even close. Terrible guessing. Obtuse, a type of triangle that has an angle that is greater than 90, that's obtuse. A polygon is a figure that contains many angles, that's the book definition. I had that in the PowerPoint that we did. It's a terrible definition, but that's the book's definition. Cylinder is a solid where there's 2 parallel circles and then the curved body that connects them. It's a rectangle that connects them. That's a cylinder. A perimeter is this distance around a polygon. It's not the distance around a circle. Circle is circumference. Perimeter is polygons. And then hexagon is a geometric figure that contains 6. 6 in hex, they have X's in them, so that's how you can kind of remember them. All right, There's your vocab. If I made a mistake, let me know, but it just came down to just vocab. Usually that's what will ruin people. All right, perimeter and area. So perimeter is the distance around, right? Most people like didn't even know the definition of above right there, but they could still find perimeter. That blows my mind. But you got to add up the walls. So add up the 9, the 8, the what is that? A 4, a 5, a 5, and a 3. When you add them up, you should get a total of 34. And yes, how I got these? These are 5s. This whole wall is 8, and this one was 3, so this has to be 5 for there. And then this whole thing was 9, this was 4, so this has to be 5, so it makes a total of 9 across, 4 and 5. They're parallel. Area, I did it 2 different ways, depending on how you did it. So I drew my little line across, so that was a 3 by 9, and the other little box was a 5 by 4. You could do it that way and make 47. Or you could have drawn the line going up and separate it to a tall block and a small block. The small block would have been 3 by 5, and this would have been 4 by 8. And so that would have been the same thing. You got 32 and 15, which still makes 47. When you do area, it's how many squares fit in the object, so it's centimeters squared, and perimeter is just the normal label, centimeters. It's the distance around. So, there you go. That's perimeter. Let's go to the next one. All right. So, triangle. To find perimeter, you just add up the walls on the outside, not the inside. So that's the 2.5, the 1.8, and the 2.9. You add those up. That makes 7.2, and it's kilometers. That's the distance around. Now for area, if you look at your property sheet, it was half the base times the height. So base, height, I even have the height marked. You multiply those together and cut it in half, and it turns out to be 2.25. The most common mistake I saw people making on these, they forgot to cut it in half, or the labels were wrong. And I told you missed points for labels. Bless you again. So labels on area is always centimeters squared. Even the surface area is always how many squares are on the surface. Perimeter is always just the label, the normal label. So there you go. Circumference and area. You had the formulas on your property sheet. It's, for circumference, it's 2 times pi times r, or 2 times r times pi, however you want to say it. So I did 2 times the radius times pi, so it was 2 times 5.1, which is 10.2 pi's inches. That's the exact answer. And then if you actually multiply 10.2 times pi, you get 32 point something, and it was inches. That's circumference, distance around. It's almost like perimeter. And now area is pi r squared. So you square the radius, which is 26.01. And then that's times pi, and it's the label for area is always squares, so it's inches squared. Now if you multiply that turns out to be 81. Again, what it came down to was just labeling. That's usually what killed people. They didn't get the right labels, they butchered them. If you missed a label, like you missed the power on it, it's a point off. I told you, the label's 1 point of the answer. So some people got wrecked by that. All right, surface area. Now we're into area again. So surface area is in squares, right? How many little squares? Volume is how many cubes are in an object, sugar cubes. So the actual property is power of 3. So that's how you do volume. Now the most common mistake people made on this this triangular prism, because I told you it was a prism. I told you it was not a pyramid, it's a prism. The base is not a rectangle. And you're looking, Ward, yes it is. You're probably looking up there going, yeah, the bottom's a triangle.
The base is a triangle.
Or, yeah, the base is a triangle. The base on this picture looks like a rectangle, it's not. The name of the object is the base. So when you say that's a triangular prism, the triangle's the base, because that's how you name it. You name it by whatever the base is. So it's a triangular prism. So, because the two walls that are parallel to each other are the triangles, and those are the bases. That's why I went through those definitions with you. So, you have to find the perimeter of the base. Well, the base is this 12, the 16, and the 20. That's the triangle here. That's the perimeter of your triangle. You add them up, and you take it times how tall the object is. Now, how tall it is the distance between the two bases. That's height. It should be depth. That was a complaint I had when we did those things in class. So it's the perimeter of whatever your base is. The base has to be a triangle. You take it times how tall it is. And then you add that times 2 times the area of the base. Well, the base is a triangle. So the base of the triangle is half the height times base. So half the 16 times 12. And then you have to double it, because that's what the formula said. You had to double whatever that area was, because there's 2 of them. And you should have got 672. And it was centimeters squared. Now, I even warn people, like let's say you were struggling at that and you're like, yeah, I don't know how to do it. I don't know how to find it. I warned you, you could always just find the area of each individual wall separately and add them all up, and that would give you surface area. So like this rectangle down here, that's 120, it's 12 times 10. This rectangle is 10 by 20, so that would be 200. This rectangle over here is 10 by 16, that's 160. Then the area of this triangle right here is half times 16 times 12, and this one back here is the same, half times 16 times 12. If you were to add up all, 5 of those areas I just pointed out, you'd still get 672. I had some people do that. It was really clever. They didn't know how to use the formula, but they definitely knew how to do the surface area for each wall. The label came down to the rest of people. All right, now, volume. You take the area of the base times how tall it is. The base is a triangle, so it's half the 16 times 12, and then the height is 10. And you get 960. And it's centimeters cubed, that's volume. So it's cubic. For the cylinder, you take 2 times pi times r times the height. So 2 times pi times the radius times the height. And then you add that to 2 pi r squared, because that's your 2 circles. R squared is 9, you take it times 2, which is 18. This is 3 times 8, which is 24, times 2, which is 48, and this is the exact answer. But if you actually multiply these out, these are the decimals you get, you add them up, you get 207. A lot of people are getting the 207, which is good. The label is what killed people, centimeters squared. It's still surface area, so it's squares. Volume is pi r squared times the height. So pi r squared, that's 9 times 8, which is 72. This is the exact answer. And then 72 times pi is 226, and it's cubic centimeters. Yeah, it came down to just getting the labels a lot. I think the goofiest answer I saw, number 6. Somebody calculated, I think, a pyramid for that one. They did all the formulas for a pyramid. That's definitely not a pyramid on number 6.
Where did they get all the numbers for that?
I don't know. I honestly don't know. I think they're just making up stuff and plugging in things. So they literally did a pyramid. So I don't know what the slant was. I don't know what the numbers were that they're using. But I just looked at it and went, yeah, no, this is right. Now, if you're going to take a retake, you got 1 week to do it this week. It's got to be done by Friday, not by next Monday. So you got to come in before after school, review with me, whatever problems you need to review. Expect brand new problems. Expect a new problem for right here. It'll be some type of non-polyhedra. Right here, number 5, expect some type of prism, any type, but it's going to be a prism, not a pyramid. It'll be a prism. Expect some type of circle. Expect a triangle. On this number 2, expect some type of rectangular figure, and then the vocab. I'm just going to pick from the chapter. It could be some of these words. Could be the words from the practice guide. Could be some of the words I skipped because we have lots of different types of polygons and polyhedras. So just be kind of ready to go. But again, you don't need to tell me right now. You can send me an email. You can stop in. You can tell me in the hallway. You can do it kind of wherever you want, but it's got to be done this week. So this week it's due. Okay, questions? If I made a mistake, let me know. If let's say you butchered a problem and I forgot to count it wrong, that's on me. I don't take points away for that, so you can make fun of me all you want. But if I made a mistake and you got it right, then I need to know that, so I can give you the points back. So that can't happen. Okay, I'm gonna walk around. I'm gonna collect. I'll put my little mask on. I want my test back. So I like to hand those out during parent-teachers conferences. Parent-teacher conferences are next week. If your parents would like to have a conference with me, I always love an opportunity to talk to parents, see kind of see the other aspect of your life, see how they influence you and how much you act like them. I know it seems weird, but it does happen. I always like to see that. You can always tell your parents they are more than welcome to come in. If they do not feel comfortable coming into school, because I know all of our strict standards where we have to have masks and whatnot, they can Zoom with me. They can just send me an email that they're interested in a parent-teacher conference, and I'll set up a Zoom for them at a certain designated time. I know I do that a lot for parents. So just if they're interested, let me know. Talk to them about it. I think the school sent out emails last week about it. I signed up for a time. But I'm available and they can even call me on the phone. So there's lots of ways to reach me on parent-teacher, so I don't have to always come face-to-face. But I always appreciate when they come in. So. All right. Everyone have a little property sheet. Yeah.
These are real numbers.
Okay, yeah, the properties of real numbers. Let's go through that. Okay. Okay, what we're going to be looking at here in this chapter, this is the third chapter that we're in. We're in logic, reasoning, right? All right, the type of reasoning we're going to be getting into is how to solve problems, right? Not just riddles and puzzles, but real problems, like algebraic problems. So that's what we're going to be looking at. So I thought the best way to do this, we probably should talk about the properties. So we're going to go through those right now. We're going to go through a couple of the names, and this is what we're going to be doing the next couple of days in here. So if you know you're going to be gone at some point, maybe you're leaving, or maybe you have some appointment or something, you've got to kind of know what we're going to be working on. We're going to be working on this stuff. The actual names for properties. My goal is to go through kind of what each of these stand for, so you kind of know. We're going to start on the top portion first. We're going to start with these 7. These are always the first ones, they're the properties of equality. Then after that, so this would be like maybe the next day or two. Then the bottom ones, I think there's 6 at the bottom. Some of them have doubles. Those are the ones we're going to be working on probably Wednesday or Thursday, Friday, sometime this week. Those are probably the more challenging ones because there's a lot of them, you don't know how to use them. It'll make sense when you actually start to see a problem. But I want to get just kind of a sense for where you're at right now. So if you can, take out your notes real quick. I want to give you a little bit of time to take your notes. Let's talk about kind of the major type of problem that I want to cover. I think the best way to introduce this is to really highlight what you have to do. This is going to be a crash course on, this is not something you probably necessarily need to know right now. This is something that we need to develop over the next couple days here. So I'm just going to give you an intro. So what I'd like you to do right now in your notes is to write down a simple Algebra 1 problem. Here's the problem I'd like you to write down. This is the example. X plus 4 equals 12. We're going to start with something easy. The book doesn't believe in doing crash courses in algebra. They believe that you should jump right into geometry proofs and facts and show reasoning and how to prove something logically. That's incredibly difficult the first time because you guys are just entering geometry and it's a different animal, as you can tell from the stuff we cover from a normal math class. But it's one of those things that I think it's important that we review some algebra facts because this skill that you have to learn is something that applies directly to geometry, showing evidence, showing work, that type of thing, coming up with the reasons why something works. All right, now, here's what I'd like you to do. On your piece of paper right now, I don't know how long it will take you. It might take you 5 seconds, it might take you 2, it might take you a minute. I want you to solve for x. Just write down what you remember, how to do it, okay? Show the work, do it. See what you have. I know it seems silly, maybe you just know the answer, you're just gonna write it down. I have no idea. No limits to it, just solve it. Well, it took you like half a second. Okay, what was the answer? What did we get? 8. Okay, so at least we got to the right answer. We got to 8. Okay, good. If you didn't get to 8, now you can start to worry. All right, now, here's the thing. How many steps did it take you to get there? 1? Probably just did in your head, it's like, oh, it's 8. Right? You just kind of know it. Maybe it took you a few, I don't know. If somebody were to walk in this room that's never done Algebra 1, let's say like a 3rd grader or a 4th grader, that's never had to see this problem before, right? And they looked at your paper for their inspiration of how to do it. Would they learn how to do it from your paper? Or would they just know the answer? That's something that's the question of questions. Would somebody actually learn how to solve it from looking at your paper? Or would they just go, well, I know the answer is 8. Okay? That's the hardest part to get through your head. It's like, I need to show evidence on why it's 8. Because I agree, it is 8. Some people will just go, well, it's common sense. 8 plus 4 is 12. That reasoning doesn't work. Sure, common sense, right? Yeah, that works for everything. It's common sense, 1 plus 1 is 2. But that doesn't help me solve that. That's just telling me the answer for it. So, somebody want to volunteer, how do you actually solve this?
12 minus 4.
Say it again?
I did 12 minus 4.
Exactly. We have to subtract 4. That is what these are. These are the properties of equality. It's an idea of how you are supposed to approach a problem to solve it later. Okay, it doesn't give me the answer. They're called the properties of equality. The properties of equality are something you do to an equation. That's an equation, it has an equal sign. You do them to both sides because you got to keep the equation balanced. Imagine that it's on an old school like scientific scale, right? A weight scale, and you want to keep it balanced. And so these properties of equality are what you do to both sides, and it makes the equation still true, even though it looks different. But the weird part about this stuff doesn't solve your problem. It doesn't solve. It's a setup to solve it later. It sets up your problem so that you can solve it later. That is the hardest part for most people to wrap their head around. It's like, why are we doing this? It's so that you can explain it to somebody else that doesn't know how to do it. And when you actually learn that process, where you learn a problem through and through, from the forward to the back, and you know every aspect of it, it makes you 10 times better at the problem or problems that it's related to. By just knowing this idea of how to set up a problem to solve it, now you're in a totally different realm of mathematics. That's why, like in college, when you go, hopefully you guys go to college at some point to get to a career at some point, they over-prepare you, right? They overkill your subject area to the point where you're supposed to know every aspect of it, front, back, right, left, everything. So that way when you get into that work field, it's not even a challenge anymore. It's just something that you are trained to do. To give you this idea of like mathematics, I had to take 56 credits worth of math in college. 56. Wrap your head around that. Just math. Okay? One math class was 3 credits. And then I had to take English on top of that, and history, and sciences, and other classes, programming, and other things. Why? To get me better at what I need to do. It's to over-prepare me to be able to solve a problem differently and to explain it the best way I can. And I know that seems a very weird concept, but it's directly applied to what you just did, right? You have to show every aspect, not just that you know how to do it, how would somebody else need to learn it, right? So, let's talk about it. You said it, right? We have to subtract 4. This is the evidence that we're doing. Okay? This is the evidence. Now, the reason why, it's right here. This is the reason why we're doing it. It's called the subtraction property of equality. The subtraction property of equality allows me at any point in the middle of a math problem to suddenly subtract things from both sides of the equation. It has to be an equation, because these are properties of equality, they only work in equations. So if your problem doesn't have an equal sign, you don't do any of these properties. So, I'm allowed to do this. I can pick any number in the world. I could have picked 1, I could have picked 2 million, I could have picked a decimal. I can pick any number. I just happen to pick 4. Why 4?
Because then you're going to take the 4 away from the side with the X on it.
Exactly. And that's the reasoning behind it, right? Yeah, you know the properties, right? You know what it means that you're going to subtract. But in algebra, they teach you that, yeah, you need to get rid of that. Because the point of the problem is to get X by itself. And by subtracting 4, you will get rid of it. So it's based on inverse operations, right? There's this little acronym that sometimes I always find it weird that Algebra 1 teachers never show you. It's called SADMET. I don't know, how many of your Algebra 1 teachers ever showed you that little acronym? It's PEMDAS backwards. It's actually written like that, right? So it's 7. When you start an equation, something with an equal sign, you always want to look to see if there's anything you can add or subtract first. Well, I had an add or subtracting problem. I could subtract 4 from the side of the x. Once I'm done with that, and I've done all the steps to get you through that process, and that's what we're going to be learning, then you go on to the next part, which is multiplying and dividing, in any order, whatever one you need to do next. And you go through those steps for how to solve that. Then when you're done, then you do exponents, and you do parentheses if you have any of those. But that little acronym is the process that we learn. All right, now, okay, that was the property of equality. That's a setup. That's all this is. Those are setups. That's all it did. Now, to go further from here, from these properties of equality, that now you've identified what we need to do. That's what the field properties are used for. The properties at the bottom of your page. That's the 6 at the bottom. The 6 at the bottom are actually the work that's needed to be involved so that it actually solves out completely. There's a lot. If you look at those, look at all those properties down there. I think I have them in italicized, and up here they're in red, but they're italicized. There's what? Commutative, or there's closure, there's associative, there's inverses, there's identities, there's, I think there's a distribution property at the very end. Is that number 6? We have lots of properties. This one is the first setup. The field properties are all the rest of the steps. In fact, to solve this problem, it takes 4 lines of work. 4. Most people do it in 1 second in their head. They're like, yeah, it's 8. I just know it's 8. Yeah, took a property of equality, took that one specifically. Now, to do the rest, this is what we're going to be learning the next couple days. Like, how do you know what property to do next? Well, that's the process. You learn this weird way of doing it every single time. So it just becomes like a motor function, how you do it. So, next step, 4 minus 4. This is on your property sheet. This is something we're going to look at the next couple days because I want to go through all the property names. You would actually, these would cancel each other out and make 0. That's a different property name. If you go back down to the bottom of your paper on the field properties, there's a property, I think it's number 5, where you can add numbers up and it makes 0, correct? They're called additive inverses or property of opposites. Called the property of opposites. Opposite numbers when added make 0. It's called an additive inverse. That's the field property where it's under, but it's called the property of opposites. If you ever talk to any of my previous geometry kids, they call it the prop of op. They just abbreviate it. So it makes 0. Now, I believe above the inverses, there's the identities, correct? That's property number 4 on your property sheet. Identities. If you add 0 to something, or you multiply by 1, that's an identity. Because identities don't change. Your identity doesn't change. You can change your hair color, you can change the clothes you wear, but your identity is still the same, right? You add a 0, you're just changing your clothing, it didn't really make a difference. It's still X. That is an additive identity. These are the things we need to learn in the next couple days. So when you add 0. And now on the other side, what's 12 minus 4? 8. The final answer that we were supposed to come up with that I had marked up here for the longest time. That property is the first property on your property sheet. It's called closure, or a better word for it, it's called substitution. Substitution, or what they call closure. It's usually the closing argument. Every problem, when it's an equation like this, every problem will take 4 lines of work. Minimum, 4 lines. And I'm going to give you the order that we always go in. This is the part that you probably want to write down. This is just an example. So the steps we always walk through. This will help you out when we actually get to the process. So today was the intro what we're going to be doing and to kind of walk through some property names. It's not that you're not supposed to be the expert when you walk out of here. But step 1, we always do a property of equality. There's some type of work that we have to do to both sides. Like you have to add 4 to both sides, or subtract 4 to both sides. Or you had to multiply by 20, or you had to divide by 2, or whatever the number is. You had to do some property of equality first. And you saw it, I did subtraction property. The second rule you always will do, you will always do an inverse. There's 2 types of inverses. There's property of opposites, and there's reciprocal. The third rule, you will always follow an inverse up with an identity. Some type of identity. There's 2 on your property sheet. There's the multiplicative or additive. And the last step, number 4, is usually some type of closure or substitution. It's actually doing the raw math. These are the steps we follow when we solve a problem, every single time. If you can remember that order, it will make total sense when you look at your property sheet and you have to go solve a problem on your own. You can show the work, you have all the evidence you need of why things work, why they turn out the way that they do. Most people are never taught this in Algebra 1. The number one complaint I always have is like, I just know the answer, and then that eventually goes away. People see the purpose of it. But then the question I always get later, after they just accept that this is how we do it, why didn't they ever teach us this in junior high or some other time? Why didn't they ever teach us these rules? Can you imagine trying to teach an elementary kid to do this? They complain about everything known to man, let alone trying to show evidence of something and show why it works, or how to teach your neighbor to do it so that it'll be the right answer every single time. I mean, the categories of real numbers, 0, doesn't even exist for an elementary kid until like 1st or 2nd grade. They don't even talk about 0, or adding 0, or subtracting 0 until 1st or 2nd grade. Because 0 is not even in their developmental cycle yet. They're still dealing with natural numbers. Then eventually they get to whole numbers where they learn what zeros are. And you're going to try to teach them this stuff with all the property names? Never going to happen. High school kids, well, don't like this stuff. But after you start doing it, then you see the purpose of it. You see why it works and how it works. And then you never have to worry about an Algebra 1 problem. You'll do it the same way every single time. You know your steps, and you never have to worry about, I don't even know if this is the right answer. You don't have to ever worry about it. Now, some people really struggle with this. Don't get me wrong. And I know that seems silly to talk about. There are some people like algebra, like using variables and numbers. It's just difficult because some people are dyslexic. Some people just don't know what steps you need to do or which property to go with. They don't understand if I'm supposed to add or subtract. I know it seems silly because some people just take it for granted. There is websites out there like SciMath. I think I have a link on my website. If you type in any algebra problem, it will show you how to solve it one step at a time. It'll just automatically walk through your problem. There's other ones called like Touch Algebra. You can type in math problems and you can just drag things around and it'll show you how to do it without making any mistakes. You just use your fingers on your touch device. All right? It's pretty clever. So if this is something you're going to get stuck on, we will make sure that it works for you. Okay, I'll find some tool that will help you out. Now, again, walking out of here today, I don't want you to feel lost. I don't want you to feel like, oh my gosh, I don't know what I'm doing. This was the intro what we're going into, not to be the expert at it today. Okay, questions for me at all? Okay, that's it for today. That's all I got. If you're going to take a retake, just tell me. If you haven't turned in any late work, missing work, page 1.9 or worksheet 1.7, or maybe there's something in the grade book you haven't done yet. I know some people turn in some stuff on Friday. I'm going to probably get them in today. Test scores, they're going to go in like right when you leave here. In fact, I might type them in right before you actually walk out and hit submit. Just so you can see what your score is going to do to your grade, because sometimes that influences whether you're going to retake or not. Question?
Do you know what you're doing next week?
Next week. For sure, we're going to be into Algebra 1, so it's either going to be, it could be expressions, or it's going to be graphing. It's some type of Algebra 1, so that's what we're going to be doing. Yeah, it depends on where we end up this week, so I'll know by Thursday, like, what we're doing next week for the homework and stuff, so it depends on what section we end on, so. And and I can get you copies of it and whatnot, so.